So the Varroa mite is an ectoparasite of the honeybee, and what that means is that they live externally on the body in the same way that a head louse would live on a human head. Varroa mites have spread globally. They act as a vector of disease. They are feeding on the hemolymph, or the blood, of a honeybee, and through that they are able to pass on various different viruses to honeybees, which then has a massive impact. So the study's aim was to see if we could detect Varroa mites in honeybee hives using accelerometers, which are small sensors that we can fit inside the hive, and they then detect the environmental vibrations happening in the colony. Originally, we thought that to detect Varroa in the hive, we would do so indirectly. So we would be detecting differences in the honeybee colony vibrational signal rather than the mites themselves. So it was much to our surprise that we could detect vibrations coming directly from a teeny tiny Varroa mite, which are only 0.5 milligram in size.
So our research is showcasing the sound that the vibrational pulse is equivalent to, and we detected it in 3 different substrates. The vibrational pulse has a completely different response, whether it's in a substrate or another one or another one. So we propose the idea that the response of the jolting vibration is picked up by the Varroa mite in order to assess the surroundings it is residing on. If you like, perhaps the jolting pulse are the eyes, they are the ears of the animal. They are perhaps an additional sense that they use in order to find out the surroundings it is on and perhaps detect a honeybee in the distance. We are revealing to the world a signal highly relevant to the mite, which is promising future use in order to manipulate this parasite, which is not welcome in a honeybee colony. The Varroa mite happens to be a parasite that, if not managed, will end up destroying the colony it is infestating.